Okay, here's the review for Unit 6. Okay, force. Symbol is big F. Okay, the force is a push or pull, and it acts to make an object move or might not move, but it's an external force. It's a vector. Examples of units, newtons. Newtons are also kilograms, meters per second squared. Now, the unit for force, or the equation for force, is force equals mass times acceleration. Now remember, acceleration can also be g. G is an acceleration due to gravity. So you can substitute g with a when you're doing weight problems. Okay, let me go ahead and erase this. Oops. Sure the eraser's on. Now, let's talk about net force. Net force is calculated by adding all the forces available on an object. Okay? Net force is capital F with N-E-T, and it's all the forces on an object. Okay? It is, again, it's a vector. Examples of units is still in Newton, but it would be force 1 plus force 2 plus force 3, and so on. Remember, forces act in pairs, so always add the two opposite forces together and then the other opposite forces. Make sure the direction, one direction positive, one direction is negative. Okay? If the net force is 0, either the object is moving at a constant velocity or at rest. There's no acceleration taking place. Okay, Newton's first law, called the law of inertia, objects move or stay in no acceleration, nothing, forever until an outside force acts on it. It's also called a law of inertia. Like if you had a pool ball going in a straight line, and then another ball comes and hits it, it will change its direction. That is Newton's first law. This pool ball would go on forever unless it acted upon by next force. Newton's second law describes the force what it is. It's mass times acceleration. Again, in Newton's, so the more massive an object is, remember mass and acceleration are inverses of each other. If the force stays the same, if mass goes up, acceleration has to go down. Acceleration goes up, mass has to go down. And third law is action-reaction. Remember, all forces work in pairs. You cannot have another force without another one. Newton's law states that for every action, for every force, applied force is an opposite equal force in its opposite direction. Remember, they work on, if two objects were putting force on each other, the force pairs are equal and opposite, but the force pair would work on one object and the other one would work on the other. Okay? Looking down at definitions, balanced means the net force would equal 0. Unbalanced means the net force would be greater than 0. Okay? To find the net force, I talked about it up there. You need to find, add all the forces together. Make sure you pair them off. How does net force affect motion? If the net force is greater than 0, then it will move. An object will accelerate. Okay, friction. How does the friction affect an object? It opposes motion.
Morning, Ken.
Opposes motion. Now you're going to be on my Explained Everything video. What direction is friction? Friction is always the opposite of the motion. Going in the different direction. Opposite of the motion. and you have to consider that when you're trying to figure out what's the total net force. If an object's at constant velocity, that means the kinetic frictional force is equal to the applied force. Newton's first law, second law, we talked about that. Mass, weight and mass. Remember, weight is a special type of force. It's mass times gravity, acceleration due to gravity. Mass is the amount of material. Now, the weight is found in newtons, so the actual unit for the gravitational field is newtons over kilograms, because the mass is kilograms. They cancel out. So 9.8 meters per second is the gravitational force on Earth. Erase that real quick. Okay, next one on inertia is the ability to withstand change. And then motion, momentum. P equals mv. That's mass with a velocity. Now, total momentum. Momentum has to be conserved, so the P initial has to equal the P final. So whatever you start with, you have to end up with.